Alright everyone, welcome back to another chemistry video with Study Buddy Tutorials. In this video we're talking about pressure. And just a heads up, if you're interested in any of these topics, just know that we'll be covering them in a video part series. And this is part 1 of this series, and then we'll be talking about pressure in this video. Part 2 will be doing some practice problems related to pressure, so I can show you guys how my mind works through when I see these pressure problems, and how you might see these problems in your test, quizzes, whatever you want to call that. Okay, so let's think for a second. I'm gonna just put these images out here. Now, looking at these images, if I ask you that which object or which shoe here would sink in the ground when I wear it, me, same weight, both shoes, when I wear it, which will sink on a grass ground, so a soft surface. Pause the video and answer that question and think about why you would say that. Alright, I'm assuming that you paused the video and thought about that, and if you already knew that, then welcome back. So the answer here is the heels. The heels would exert a higher force than the sneakers here. That is because the heel, if you see, I'm going to change my pen, there is the part where it's making contact with the surface is this little part, and then this small heel, leaving all of this part in the air, if you want to call it. This part depends on these two parts here to hold us up, versus a shoe, there's just this whole little sole here that is touching the ground. So here the heel has a high force, so a higher force per unit area, and then the shoe here, or sneaker, tennis shoe, flat-toed shoe, whatever you want to call it, has a lower force. Now we'll talk about this in terms of pressure, but the idea that heels sink in versus sneakers don't is related to pressure. So pressure is created when gas particles collide with their container walls. So this we'll get into when we do a little bit more on gas laws and all of that, but just know pressure is created when gas particles collide with their container wall. Alright, so we have this illustration here. It says air pressure is all around us, and we have this lady here. She's standing on Earth, and it has these arrows. So air or atmospheric pressure is exerted on us in every direction, up, down, side to side, bottom, whatever you want to call it, all directions. Now, just a little backstory on air pressure. Earth is surrounded by an atmosphere that extends into space for hundreds of kilometers. Because the particles in air move in every direction, they exert pressure in all directions. This pressure is known as atmospheric pressure or air pressure. Now, the question here says, why does air pressure vary at different points? We know that air pressure varies at different points. This is because gravity is greater at the surface of Earth. There are more particles towards the higher altitudes, where the force of gravity is less. Just follow along here. Fewer particles at the higher elevation exert less force than the greater concentration of particles at lower elevation. You don't have to memorize this, this is just a theoretical question that people have. Therefore, the air pressure at the higher altitude is less than that of at sea level. Another thing that I was going to throw it out there, it's just an interesting fact to know. At sea level, atmospheric pressure is about 1 kilogram per square centimeter. Now, that's the number. I'm not sure if your teacher's going to ask you to memorize it, but just ask them. But how did I calculate that number? Did I just think of it, a random number, and then throw it out there? No. There's a systematic approach to doing everything. And we'll talk about the mathematical representation of pressure, meaning the math equation, how we solve pressure. So, pressure is officially defined as the amount of force per unit area. So what that means is amount of force per unit area. If I look at that literally, and coming from that math background, I know that per means division of some sort, right? So I'll have this equation coming up here. Pressure is equal to force over area. So I know that this per, it makes sense too, right? Force per unit area. Per means this division sign or fraction over here. Now, what about the units? So let's move on to the next slide here, the units. So we have this equation, pressure equal to force over area, and I'll just say this out. 1 unit for pressure is derived from the equation Newton over meter squared. So the SI unit for pressure is pascals, PA, that's abbreviated as PA, and pressure can be measured in atmospheres. So basically, this all depends on what you're given. So pressure can either be atmospheres or it can be pascals. Force is written as newtons, and then area is in meters squared, which is why this is there. Alright, so that is the last of our content that we covered in this video. Next video we'll be talking about practice problems. We're doing some practice problems, around 10 practice problems, and stay tuned for that. This should be the next one in the queue. Or you can go back to my YouTube channel and look it up there. But yeah, this is a continuation to the part series of gas laws, pressure, and the molecular theory. Okay, again, if you need tutoring or have any questions, suggestions, email me at that email. The email will be in the description below, and it should be the first comment as well. Additionally, if you want to email me, you can add it to a comment, and I'll look at it there and I'll respond to you. Yeah, so thank you for watching the video. Don't forget to like, share, subscribe, and comment down below. Alright, see you guys. Bye.